Why is any number to the power of 0 1? 0 exponent rule. Imagine you have a magic box that multiplies a number by itself. When you do this a few times, you get bigger numbers. But what happens if you try to multiply 0 times? That's where the idea of raising a number to the 0 power comes in. It might seem strange at first, but it actually makes sense once you understand the rules of exponents. Think about the basic idea of exponents. If you have a number like to raise to the third power, written as 2 cubed, it means 2 times 2 times 2. That equals 8. Now, if you reduce the exponent by 1, you divide by the base number. So, 2 cubed divided by 2 gives you 2 squared. That's 4. If you keep doing this, you see a pattern. Each time you divide by 2, the exponent drops by 1. When you get down to 2 to the first power, it's just 2. If you divide that by 2 again, you get 2 to the 0 power. But 2 divided by 2 is 1. So, 2 to the 0 power must be 1. This pattern works for any number except 0 itself. Because dividing 0 by itself doesn't give a clear answer, 0 to the 0 power is considered undefined. This rule is not just a coincidence. It's based on the rules of exponents that keep everything consistent. If we said 0 to the power of 0 was anything else, like 0 or 2, it would break the rules we use in algebra and calculus. So, defining any non-zero number raised to the 0 power as one keeps the math logical and simple. Another way to see this is to think about what exponents really mean. They tell us how many times to multiply the base number by itself. When the exponent is 0, it's like saying you are multiplying 0 times. The only number that makes sense as the result of doing nothing is 1. It's the identity element for multiplication. That means multiplying by 1 doesn't change the number. So, in the world of numbers, raising any number to the 0 power is a way of saying you're doing nothing to it, and the result is always 1. This rule helps keep all the rules of exponents working smoothly, especially when working with larger numbers or more complex formulas. It's a simple idea, but it's a key part of understanding how numbers behave when you start to play with powers and roots.